What is computational thinking and how should it be taught? By Catherine Jones. Computational thinking is, according to Google, a set of problem-solving skills and techniques that software engineers use to write programs that underlie the computer applications. However, this reference to engineers makes me question how it is a relevant concept to use within a primary school environment. For example, Barr and Stevenson explain how making computational thinking relevant to young children can be especially challenging. Although the new National Curriculum Framework explains pupils should use computational thinking to understand and change the world, suggesting the government's thinking is that children can be taught how to engineer software even from a primary school age, and that the potential for their skills within this area to progress is vast. This is supported by Barr and Stevenson, who explain that whatever the definition of computational thinking is, it should include examples of how it can be taught within the classroom. This view presents computational thinking as the ability to think as a computer scientist, problem solve and debug or fix things. These differing ideas about this complex concept highlight how it's still a developing idea, and as Brennan and Resnick explain, there is little agreement about what it encompasses. Google unpicks 4 different aspects of computational thinking, which I think presents the concept more clearly, the first of which is decomposition. This is the idea of breaking down a problem to make it easier. Secondly is pattern recognition, which is supported by Gamma et al., who explains the importance of this aspect in crafting complex systems has long been recognized. The next aspect is algorithm design, which is a sequence of instructions which can, according to Berry, result in massive savings in terms of both cost and time. For example, Tony Hoare invented the algorithm called quicksort, which is a more efficient method of sorting objects than the previously used algorithm called bubble sort. Quicksort is now used internationally to sort different objects. The final aspect is abstraction, which I think is the unique quality of computational thinking, as it allows you to modify or simplify reality. For example, when creating an electric circuit, the components can be represented digitally and then easily applied to the concrete version. This more detailed definition helped me understand how the concept of computational thinking can be applied in primary schools and how it should be taught. I think computational thinking, similarly to other subjects, should be developed through practical activities when possible. This is supported by Berry, who explains when teaching the computing curriculum, look wherever you can for practical creative projects. For example, when teaching the algorithm of quicksort, if children sort concrete objects, they may find it more engaging and memorable. Within my block school experience, the children used this method in the role-play area of a post office to sort parcels that weighed different amounts. This concrete experience could easily be modified digitally. For example, children could use a program called Scratch in order to sort a large range of different objects and numbers. This made me realize computational thinking can be developed and applied across all areas of the curriculum. For example, Barr and Stevenson present how computational thinking could be used in a science lesson for collecting data from an experiment. This approach is similar to Laurilard's idea of learning through practice, when she explains it is an essential part of the learning experience. This idea allows children to work through concrete experiences, which I think is particularly important when developing computational thinking, as first-hand experience will help to develop a deeper knowledge. For example, allowing children to try to debug or fix things for themselves could help their understanding of computer science grow. Sennett supports this by explaining it is by fixing things that we often get to understand how they work. In conclusion, the concept of computational thinking is vast and complex, making it difficult for a teacher to grasp and therefore teach. However, it helps children to develop a range of skills which can be applied not just to computer science, but within all areas of the curriculum. It is therefore an important aspect to teach effectively. As Berry explains, it can help children to conceptualize, understand, and use computer-based technology, and so are better prepared for today's world and the future.